Okay, the last piece in 3.3 was piecewise graphing. Okay, so I'll just quickly explain the concept. Piecewise graphing looks something like this. So maybe f of x, so this is piecewise. Piecewise graphing looks something like this. You'll have two or more functions, but you're only going to want parts of them. So for example, if we did x squared, but only if we're between -1 and 2, and then let's say here we did 1 over x, if we're greater than 2, okay? You can think of it as two graphs. In fact, if you want to lightly graph x squared, you know that x squared goes through -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. So I mean, this is essentially what it looks like. And I'm not gonna, this is not my final answer, but that's certainly what x squared looks like. And now 1 over x is the reciprocal function, and I know that at -1, -1, we have a point, and we got these little branches down here, and then we have same thing up here in the first quadrant. Okay, so the orange graph is the entire graph of 1 over x, and the black graph here is the entire parabola. But now, here's where these restrictions come in. Okay? If I'm only looking at this parabola from -1 to 2, then that means that when x is -1, which is here, this vertical dotted line, and when x is 2, I should only be focused on this parabola, meaning that I only want to look at my parabola between those two values. So I'm going to erase the 1 over x graph. Okay? And now anywhere outside of that, I have a different rule. 1 over x. So what does that mean? That means that outside of -1 and outside of +2, I don't want to look at the parabola. So I'm going to erase that piece right here. Okay, and let me just make that a little darker. So we have a closed circle because it's equal to at -1. We have a closed circle at +2 where we get an output of 4. But now I don't want anything to the right of that. Okay? So there's what the x squared graph looks like only from -1 to +2. So now what happens here? I want to use the reciprocal graph where x is greater than 2. Well, that's fine. That means that I don't want anything to the left of this x equals 2 line. So I don't want any of this at all. The only part of 1 over x that I want is the part that's to the right of x equals 2, but I have an open circle because it's not equal to. So I'm going to put an open circle here. Okay? And if you want to color it in or a little darker, essentially this just keeps going and gets smaller and smaller. Okay, so here's one piece, here's the other piece. Okay, that's piecewise functions. Okay, and we'll talk more about applications and things like that for where you might see these later on, since I just want to review the skills to make sure that you guys know what to do. If we might wanted to change these functions a little bit, so you should know the 6 basic parent functions here, but certainly if I could, maybe do things that might try and trick you a little bit, like change it from x squared to x plus 1 squared. Maybe make this 1 over x, but then add 1 to it. Okay, if that's the case, and you don't know what it's going to do to the graph, you could literally plug in these values. Okay, so I mean, here it's telling you essentially to create a table from -1 to 2, get your outputs. So plug in -1, you get 0. Plug in 0, you get 1. Plug in 1, you get 4. Plug in 2, you get 9. So then you only graph these points, you connect those points with closed circles, and there's this part. Okay? This is telling you to make a table of values for this function, which I changed to 1 over x plus 1, but do values 2 and higher. So 2, 3, 4, and so on. You plug in 2, you get 1/2 plus 1, which is 1 1/2. You plug in 3, you do 1/3 plus 1, which is 1 1/3. Plug in 4, you get 1 1/4. Plug in 5, you get 1 1/5. Okay? And then you have some points that you can graph for this part of the graph. Okay, so piecewise functions are actually very easy. They're telling you what values to plug in. So if you don't know what the parent functions look like, or if they're a little bit modified like these two are, this tells you what points to plug in and use to get the picture. Okay.